All right, Jennifer, thank you. 7:25, time for part 2 of our Chemist Corner segment. Jesse Miller from the U of I rejoins us, and you're trying to run the building off lemons this morning?
Well, yeah, if we had enough, we probably could.
That'd be good. I'm sure the Russ upstairs paying the Ameren bill would appreciate that.
As expensive as lemons are right now, I don't think that would probably be as economically feasible as some of the other alternatives. But however, we're talking about batteries. I was talking about redox reactions, and batteries work from reduction and oxidation, just like we had before here in the first segment.
Sure.
And as I said, when I showed the silver, and the silver tree as we like to call it, the silver plating out on there, there's electronic transfer between the two, but it's not very useful. So when we want to make it useful, we separate the metals. Okay, and we have, in this side, there's zinc, and on this side is copper, just like you would buy, you know, a Duracell battery or whatever. It's usually copper zinc batteries. And there's an electronic potential difference between the two of them, the reduction potential difference. And so if I hook up a negative lead onto the zinc side and a positive lead on the copper side, you can see I'm getting about 1.3 volts. Now, in theory, it should be about 1.4, but there's a lot of, you know, these things are corroded, and you know, I just grabbed it out of the lab this morning, so it's not as good. So this is how a battery works. We got electrons flowing from one to the other through this salt bridge here, and this is exactly how a battery works in your little D cell or C cell or AAA, whatever it is that you got. In that case, it's in a solid matrix, but it still works the same way. You have two dissimilar metals in an electrolytic solution, and you'll get that. NiCad is nickel cadmium. There's all sorts of different designs for batteries depending on what amperage you want and things like that. Clocks don't take very much amps, so it doesn't take a lot. If we reverse that process, however, and we actually cause it to go put a potential using an outside source and flow it through it the opposite direction, we can actually plate one metal onto another. So in here I have copper in a copper solution, but I have a copper plate, and I have just a spoon I pulled out of my silver drawer. It's stainless steel, and by putting amps or enough current through here, I can actually get the, now I don't want to touch this because I got quite a bit of current going through here, so I'm going to turn this off first. I've had this going here for a little bit, but we can see that we're starting to plate copper onto this stainless steel, which is kind of cool. And this is how they chrome plate bumpers on your car. Well, they don't do that anymore. But back when they used to chrome plate things, this is the way they would do it. Cadmium plating, silver plating is done the same way. And then, just for fun, I thought, you know, a lot of kids have science projects that do, and you told me that you tried to once get a potato clock to work and things. And the way it works is the same way. It really doesn't matter what the medium is as long as it's an electrolytic solution. Now the lemons have citric acid in it, which is a good carrier for electrons. And I have a copper wire in here, and I have zinc plates. Which you can use galvanized nails, because galvanization is just zinc-coated iron or steel. And as you can see here, if we can get this, we're getting a pretty good. Yeah, we're getting some voltage. There we go. We're getting about a 1.4. Okay, so this is about equivalent to a AAA battery. So if we had a nice clock, I couldn't get a timer to work because there's not enough amperage. But if we had a clock, we could hook this up to it.
That's nice.
And we get it to work.
All right. Well, you know, Russ may be watching this at home, and he may want you to come in and try to run the lights off or something else. I don't know.
We'll get a lot of lemons.
Yeah, there you go.
Maybe some potatoes.
Okay, very good. Well, Jesse, great experiments here, and we'll get the power bills down in the building. That way we'll maybe get you some more toys to play with when you come in.
We'll get you a bicycle.
That'd be good. All right, well, thank you very much for coming in. You want to see a replay of this segment, just go to our website, illinoishomepage.net. Click on